So today we are doing daily problems again. So this is House Robber today's lead for daily problem. It's so famous that every one of you must have done it. So let's just quickly discuss it. The problem is you have been given an array and you can choose elements from the array and you need to maximize the sum of the chosen elements. But the thing is that you cannot choose adjacent element, right? uh, Robbing a street. Constraint is robbing each is the adjacent house has security system. It will automatically if two adjacent houses are broken into night. So you need to revenue an amount of money in each house, maximum amount of money that you can rob without targeting the policeman without choosing the adjacent element. So it's just simple that if you choose in one, you can't choose two, you can choose three. And you can't choose this one, so that's four. If you choose this two, you can't choose this one or this three, you can choose this one, then answer this three. The max answer is 4, right? So that's what you need to do. It's simple. Int n is equal to a dot size just for this, and then a for loop equal to 0 I less than n I plus plus, and dp of I it will be equal to max of dp of I minus 1. The Without choosing this, what is the max value you can make till now? For example, you are at current index 3, and you are not choosing 3, so it means that you can choose 2. So you can have like whatever the maximum amount that I can make up till 2 is the amount that I can make up till 3. But also, if I need to take this 3, if I need to take this a of I, then I can't just a of I minus 1. I can take this like the maximum that you can take up till this plus this number you can take now. So a of I plus dp of I minus 2, that's about it. And let this return dp of n minus 1, because that's the thing. N minus 1 represented what is the maximum sum that you can make up till this n minus 1 index, yani ki last point. So let's create a dp array of n, right? And if your n is equal to 1, right, then you just need to return a of 0. Doesn't make sense, right? And then dp of 0 is equal to a of 0, and dp of 1 would be equal to max of dp sorry a of 0 comma a of 1. Like for example, if you have only one element, the answer is just the first element. If you have two elements, then the answer is max of these two elements, because you can't take both elements because they are adjacent obviously. And then this is the for moving ahead, iterating through the array, and that's about it. And just make this a. Okay. Actually, you need to start from 2, because there is no need to start from 0 and 1 index. The answer for that is fixed, right? We have just discussed this over here, and try quickly sum it up. Whew. Yeah, it's exactly same code. I don't know why it's 0 and 5 in this case, but yeah, that's about it. So pretty simple question. Let's move to the second one. This is a complement. How can I remove this? Let's say just, yeah, this is the problem statement. GFG problem of the day. You are given a binary string, okay, 0 1 key form, and then you have to choose any two index L or R. Okay, so this is basically range between L to R, and complement the characters present between L to R. So basically, you will see L to R and you'll make 0 to 1, 1 to 0. By complementing, we means just change the character 0 to 1 and vice versa. The prof is at most one operation you can do. Okay, only one operation at most, right? You can either have no operation or you can do one operation. And so the final string, that number of ones should be maximized. If there are no need to complement, like in this case, all the numbers are 1, you no need to complement, just return minus 1. Else return the two values denoting L or R. If the multiple solution, then print the lexicographic smallest pair. Okay, that's about it. But the thing is, you need to see what is the maximum number of zeros which are there in a particular thing. And like for example, let's take a good example like this. So if you can just flip this 0, then you will make the string like double one, and then same copy ditto, right? But the thing is, like, you just made one index good, right? You can just perform this operation once a time and you have done it, so you can't do it for these 0. So maybe you would like to say that, okay, let's change this portion. First of all, what is the number of ones in this case? Like for example, initially the number of ones would be 1 2 3 4, I can see, right? And now you made just one more one, so it would be 5. So there will be another case when you see this range. Okay, let's make this range a good. Why I'm not selecting this range? Because you know there is no need to select this one, because it just flips your 1 to 0. So why do that? Let's just take this, right? And you can take all this also, that will give you +2. But yeah, because this 0 1 pair doesn't affect, like if you take this complete, or then the answer would be +2 ones, and if you take this two, then answer would be +2 ones. So in any case, let's take this 0 1 1 and then so on. So in this case you get a +2 ones, right? You get 6. Otherwise what you can take this 0, but that doesn't make sense because this 0 1 will cancel out each other, this 0 1 will cancel out each other, and this 0 1 will cancel out each other, right? So the only thing which you can get maximum is 6. And what is the range, like so you have to range that you should print starting from 0 and ending at 3, right? So yeah, that's about it. It's basically how can I say? Let's put into that in this, like whenever you see 0, you will add 1 to your count. Okay, you are maintaining a count variable. Whenever you are seeing 0, you will add 1. When you are seeing 1, you will add -1, right? And then now count becomes 0, because there is no need to perform operation at the string. But whenever you see 0, you again do 1. So if you do operation on the string, you will get a +1, right? Then you will do +2. Then you will do -1 if you see 1, then 2 if you see 0, then 1, -1, then +1, then -1. So that's about it. If you select complete range, you will get +1. So what you need to see कि इसमें where do you find maximum, like here you find maximum, that if you select this range, then you get a +2, and even if you select this range, you get a +2, and even if you select this range, you get a +2, but you need like the graphically smallest. So the उसके लिए तो simple है. Like that is very simple. Like you don't need to check when that 2 is appearing again. You will only modify the LR if the number is like count value is increasing, right? Like if you get 3 instead of 2, so then you will change it. Otherwise, if there's 2 and 2, you don't need to change it, right? And then this is the whole stuff. But now you got to know that okay, maximum I can add up to this 2. But wait, let me wait for a second. How you gonna determine what is the length? So for example, you can say okay, this 2 is coming from this, maybe this 2 is coming from this, that you need to do, right? So it's something like a combination of cadence, because what I did over here is was cadence, like maximum subarray sum. This is the maximum subarray sum up till this point. If you say this subarray sum, if you consider 0 as +1 and 1 as -1, the maximum subarray sum is 2 in this case, right? And this is the range. So it is cadence plus some a sliding window type, where you keep track of your window also. So let's take this I is equal to 0, count is equal to 0, and cur is equal to 0. This is about cadence algorithm, count and current. Now you will do for loop for int I in j is equal to 0, j less than n, and j plus plus. You'll see if your str of j is equal to 0, then you need to do what? Count plus 1. Count plus 1 by cn plus plus, else you'll do cn minus minus. Then you'll see if your cn is greater than your cr, you'll do change your. Okay, now let's make a answer vector which you need to return. And it will be consist of l or r, right? The indexes, let's make it -1. Okay, let's do this. And a is equal to your I plus 1, this is the starting point. J plus 1, this is the ending point, right? Why this plus 1? Because for their indexing start from 0, our indexing start from 0, but he want the indexing from 1. So that's why this plus 1. And let's say if your count becomes negative at a particular stage, you don't want to take that. You'll just do I is equal to j plus 1, because whatever happened till now, for example, a on this case, it never got 1. But for example, if there was double 1 in this, right? So yeah. let's say is 1 and then 0, then again 1, then again 0, then minus 1, right? Minus 1 would have come just because of this, and just because of this there would be minus 2. So whenever minus 1 will come, you will say, okay, I don't need to see this range, let's move forward. Let's start from this point, right? Let's start from this point because yeah, you already got that answer according to this range. Due to this, like when this became let's say this became 1, then count is equal to greater than current, which is 0. For example, like this 0, count is greater than 1, you just add it, and then over there the count is again same as, so you don't need to add it, right? So the only thing which you need before this index is this 0. And then when you see it going negative, you'll say, okay, let's start from here. Again it's getting negative, let's start from here. Again, let's start from here. So that's about it, and yeah, that's about it. I is equal to 0 and make count is equal to 0. You need to return a. Let's sum this up. Okay, watch this up. Else minus I plus 1 j plus 1. Oh yeah, I need to do one thing. Current is equal to count as well. Cn. Okay, so guys, that's about it. Bye.